For this video, we are going to be discussing factoring trinomials. So we've already factored a monomial out of a polynomial. And today what we're going to be discussing is how to factor a trinomial into two binomials. Taking a trinomial, which is an expression with three terms, and factoring into two binomials that have two terms each. Now what's important to remember is our trinomials need to look like this. ax squared plus bx plus c. Our biggest exponent is going to be a 2. These are called second degree polynomials. And we want our expression to go in descending order so that it's x squared, x, and then our constant. In order to factor, it's got to be in this order. Now, not all polynomials can be factored, and those that can't are called prime polynomials. And we'll get into exactly what that means here in a few minutes. So let's look at the procedure for this. The procedure for factoring out a trinomial into two binomials looks a little confusing at first, but if you follow all the steps, you should be able to get it pretty easily. So our first step is going to be to factor out any greatest common factor. Now you've already done this in our last video, so you should know what you're doing. Then we're going to multiply our a term times our c term. So I've got ax squared plus bx plus c. I'm going to multiply a times c. And then I'm going to use this little box up here to figure out two factors of a times c that can add to get b. So two numbers that multiply to get a times c and add to get b. This box should look familiar because we did an activity involving figuring this sort of stuff out in class the other day. Next step, we're going to split b into the two factors that we find here. We're going to group the polynomial into two groups based on our common factors. We're going to factor each one of those groups, and then we're going to factor out a common binomial. So I'm using factoring a lot here. This procedure looks a little confusing, but we're going to go through a few examples, and I think you'll get the hang of it. So let's look at example 1. We want to factor x squared plus 5x plus 6. So let's follow our steps on this. First step is to factor out any greatest common factor. Well, I've got x squared, 5x, and 6. Those don't have any greatest common factor, so let's skip that step. Next step is to multiply a times c. Now you know that a in this case is 1, so I'm going to multiply 1 times 6. 1 times 6, which gives me 6. All right. Now, and my b is positive 5. So now my goal is to find two numbers that multiply together to get 6 and add together to get 5. So let's figure that out. Factors of 6. Well, that's like 1 and 6. Those are factors of 6. 1 times 6 equals 6, but 1 plus 6 equals 7, not 5, so I don't want to use these. How about 3 and 2? 3 times 2 equals 6, and 3 plus 2 equals 5. So these are the two terms that I want because they multiply together to get a times c, and they add together to get b. So now what I'm going to do is I'm going to take my b term here, and I'm going to split it. 5x becomes 2x plus 3x. All right, all I do is I take this term and split it into these two. Now I bring the rest down. X squared and 6. All right, so I've multiplied a times c, I found the two numbers, and I've split it into the factors. Okay, now I want to group, and grouping is really easy. I just take my first two terms and my last two terms. Now I'm keeping the sign in here, and that'll come into play later when we've got some negatives, so always want to make sure you take that sign. So now I've grouped them. Now I want to factor each group using the greatest common factor. So basically, I want to take this binomial and pull out the greatest common factor, and this binomial and pull out the greatest common factor. So if I do that over here, x squared and 2x, the greatest common factor there, is x. X squared divided by x is x. 2x divided by x is 2. I want to do the same thing with 3x plus 6. 3x and 6 share a positive 3. What's left inside? 3x divided by 3 is x. 6 divided by 3 is 2. So I get 3 times x plus 2. So now all I've done is I've just factored each one of those two groups. Now what you should notice is that this is x plus 2 and this is x plus 2. This is what I mean when I say the common binomial. If you do this correctly, what's left inside the parentheses should be the same in both places. Now, if you think distributive property, this is x plus 2 times x plus x plus 2 times 3. So I can pull that x plus 2 out. And then, what am I multiplying it by? I'm multiplying it by x, and I'm multiplying it by 3. So I've factored out the common binomial. So there we go. I've taken my original trinomial and factored it into two binomials. Now let me show you how you can check your work. Got x plus 2 times x plus 3. We know how to do this multiplication. Just do the distributive property twice. And if we're right, if we did this correctly, we should come out with x squared plus 5x plus 6. So x times x squared. X times 3 is 3x. 2 times x is 2x. 2 times 3 is 6. Combine our like terms. 3x plus 2x is 5x, so I get x squared plus 5x plus 6, which is our original expression here. So I did this correctly. My answer is x plus 2 times x plus 3. So just got to follow this sort of checklist, this procedure, and we will get the correct answer every time. So let's take a look at another example. Here I've got 2x squared minus 5x plus 2. First step, factor out any greatest common factors. Well, 2x squared, 5x, and 2. These two share an x. These two share a 2, but they don't all three share any greatest common factor. So we skip it. Next, I want to multiply a times c. That's 2 times 2, which gives me 4. My b is negative 5, and I want to make sure I'm careful to bring in that negative sign, negative 5. All right, so now I need to figure out two numbers that multiply to get 4 and add to get negative 5. Well, factors of 4. 1 and 4. Well, 1 times 4 is 4. 1 plus 4 is positive 5, not negative 5, so those don't work. 2 and 2. 2 times 2 is 4. 2 plus 2 is 4, not negative 5. Those don't work. Well, am I in trouble here? Do I have any other factors of 4? Well, what if I use negative numbers? What if I say, for example, negative 2 times negative 2? Negative times a negative is a positive. 2 times 2 is 4. Negative 2 plus negative 2, well, that's negative 4, so that doesn't work. How about negative 1 and negative 4? Negative times a negative is a positive. 1 times 4 is 4, so that works. And negative 1 plus negative 4 gives me negative 5. So these are the two factors I want to use. So negative 5x becomes negative x and negative 4x. So I've got 2x squared minus x minus 4x plus 2. Go ahead and group my last two terms. Make sure I bring in the negative sign and my first two terms. Now let's go ahead and figure this out. I've done this step, I've done this step, I've done this step. I need to factor each one of these using greatest common factor. Well, 2x squared and negative x, they share an x. 2x squared divided by x is 2x. Negative x divided by x is negative 1. Negative 4x and 2, well, they share 2. Negative 4x divided by 2 is negative 2x. 2 divided by 2 is plus 1. Wait a second. Now we got a problem. 2x minus 1, negative 2x plus 1. You should notice the signs are all messed up. Well, how can I fix that? One way I could fix that is saying, well, how about instead of bringing out positive 2, what if instead I factor out negative 2? Negative 4 divided by negative 2 is positive 2x, and 2 divided by negative 2 is negative 1. Now they're the same. So you notice this time I had to bring out a negative 2. Now sometimes you'll have to do that. Sometimes you might not know it until after you've already pulled out a positive number. But the key is that if you might have to pull out a negative number to get these two to match up. Now that they match up, I've done my factoring. I know that 2x minus 1 is one of my binomials. It's the common one. And in my other parenthesis is just whatever's left over, x minus 2. And I've got my answer. Check my work. 2x minus 1 times x minus 2. 2x times x is at 2x squared. 2x times negative 2 is negative 4x. Negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. Combine my like terms, I get 2x squared minus 5x plus 2, which is my original expression. I don't know why I'm circling this. Should be circling this. Is my correct answer. All right, so let's check out example number 3. We got 6x squared plus 26x minus 20. So let's go through this. First step is to multiply or factor out any greatest common factor. Well, you notice 6, 26, and negative 20, those are all even numbers, so I can factor out a 2. This becomes 2 times 3x squared plus 13x minus 10. All right, factor out my greatest common factor. Now, this 2 can't just disappear. All right, I'm going to have to bring this all the way down, and that 2 is going to have to be multiplied in my final answer. However, I don't really need to use it for the rest of this procedure, so I'm just going to kind of ignore it until I get to the end, but I've got to make sure it's there, otherwise my answer won't be correct. Okay, so now that I've figured out the greatest common factor, I need to multiply my a times my c, so that's 3 times negative 10, gives me negative 30, and my b is 26, no, my b is not 26, it's 13, my b is 13. So I need to find two factors of negative 30 that add to 13. Now I can make this easier on myself by realizing this is negative. So I know one of my numbers needs to be positive, one of my numbers needs to be negative. So what if I just used 3 and negative 10? Well, 3 plus negative 10, that's negative 7. That doesn't work. How about positive 10 and negative 3? Well, 10 minus 3 is 7. That doesn't work. What if I used 15 and negative 2? 15 times negative 2 is negative 30. 15 minus 2, 13. There we go. So negative 2 and 15, those are going to be the factors that I use. So I'm going to change this to 3x squared plus 15x minus 2x minus 10. Now you notice I grouped 15 with 3x squared and negative 2x with negative 10. The reason I did that, negative, negative, just helps me to keep numbers with the same sign, positive, positive, together. Group them. Factor out the greatest common factor here. 3 and 15 share a 3. X squared and x share an x. 3x squared divided by 3x is just x, and 15 divided by 3x, or 15x divided by 3x is 5, so x plus 5. Over here, negative 2x and negative 10, those share a negative 2. Negative 2x divided by negative 2 is x. Negative 10 divided by negative 2 is plus 5. Okay, factor out my common binomial, x plus 5. Put everything else together, 3x minus 2. And now I can't forget, I gotta stick that 2 on the end, otherwise my answer isn't correct. Just stick my 2 on the end. Now I have 2 times x plus 5 times 3x minus 2. All right, well, let's check our work and make sure we're right here. 2 times x plus 5 times 3x minus 2. All right, so what I'm going to do first is I'm going to multiply 2 times x plus 5. So 2 times x is 2x. 2 times 5 is 10. Now I have 2x plus 10 times 3x minus 2. Just did my distributive here. I don't have to distribute it again. I just have to distribute the one time. 2 times 3x is 6x squared. 2x times negative 2 is minus 4x. 10 times 3x is plus 30x. And 10 times negative 2 is negative 20. Combine my like terms. 6x squared, Negative 4x plus 30x is plus 20x, 26x, and minus 20. This matches my original expression, so my answer is 2 times x plus 5 times 3x minus 2. Important that we have that 2 on there, otherwise the whole thing doesn't work. All right, and our final example for today, which I mistakenly left the answer on here, but let's talk about why that's true. Okay? If I look at this problem, I've got 3x squared plus 18x plus 2. All right, let's go through it. 3x squared, 18x, and 2, those don't have any greatest common factor, so we'll skip them. Let's multiply our a times our c. 3 times 2, 6, 18. All right, now, let's see if we can come up with any factors of 6 that add to 18. Factors of 6, 6, 1. Well, 6 plus 1 is 7. That doesn't work. Negative 6, negative 1. Negative 6 plus negative 1, negative 7. That doesn't work, that doesn't work, that doesn't work, that doesn't work. 3, 2 adds to 5. Negative 3, negative 2 adds to negative 5. Those don't work either. Well, now we got a problem. That's all the factors of 6. None of them add to 18. What am I going to do? Well, the answer is we're going to do nothing. This is a prime polynomial. It cannot be factored, so we call it prime. All right, anytime you do a times c and you can't find any factors that add up to b, it's prime. Scrap the whole thing. Just say it's prime. There's no way to factor it. We're done. So this is a prime polynomial because there are no factors of AC that add to get b. All right, so now that we've got through that long video with lots of steps, here's your here's your try it problem for tonight. You need to factor x squared plus 9x plus 18. Give you a hint, it is not a prime polynomial. So you should be able to factor this and come up with a binomial or two binomials that this factors into.